Now we're going to do some examples using these three rules. And all we're doing is either going in one direction from this direction to this direction or vice versa. So we write each expression as a sum, difference, or product of logs. So right now I have written this expression right here. And what I want to do then is go from this side to this other side. So we call it expanding. So sometimes we'll call it expand, or the command is expand the log. So I'm going to start with what I have here. Natural log of x squared to y cubed. So the first thing I notice is I have a product. So I'm going to use the product rule or the product identity. Again, here we call them rules, but in trig, all of a sudden they become identities and they're really known as identities. And now again, I want to write as a sum, that difference or product of logs. So product of logs. I'm going to now use a power rule and bring this down. So I want to get this to its most basic log form. And what is its most basic log form is just natural log of just the variable or the number. And you'll notice that what's happening here, these are two transformations. Taking the natural log of x, and I'm stretching it by a factor of 2. Here I'm taking the natural log of y and stretching it vertically by a factor of 3. But I've done it. That's it. How about this one? Rewrite each expression as sum difference of product of logs. So again, I'm going to start with my log 4 2x cubed zy cubed. And what is the first thing I'm going to do? Well, again, it's be better to start off with this division because I have these top and bottom. I need to break this apart. So I'm going to use the difference, the quotient rule here, which says that the numerator goes here and subtract the denominator. Like so. Fantastic. So now, what do I do? Well, I'm going to continue breaking this apart. Now here I have a product, so I'm going to break up that product. And here I'm going to do the same, but because I'm about to expand all this, I'm going to put parentheses here. Because, again, I want to subtract everything. If I don't put parentheses, then it won't be expressed correctly. So, and now I can use the power rule. And other thing is, so can I do anything with this one? Yeah, I'm going to just leave it alone. But I'm going to use the power rule and bring this down. And I can make sure that I'm putting all the base. I forgot the base there for a moment. We got rectify that. And now I'm going to distribute this negative across and use the power rule to bring that down. So it's a couple of things. I'm going to, again, I want to do is subtract everything. So I'm going to subtract this as well, and then use the power rule and bring this down. There. I fully expanded that expression. So all I'm doing is practicing using these expressions. So both cases I've expanded it. So we can also need to go in the opposite, which is condense or contract. Basically do a single logarithm, if it's possible. All right, so now let me go and do that. I'm going to just do this from left to right. I'm going to take care of the powers first. So when I'm right, 2 log 7 of x minus 4 log 7 x plus log, and then I'm going to just rewrite this one a little bit. So I'm already rewriting it from the original. So dividing by 3 is the same thing as multiplying by a third. So you'll notice that because I have this power rule that is a multiplication, I'm going to change it so it's easily recognizable. That's what I'm doing. Dividing by 3, same thing as multiplying by 1/3. Then I write the resulting expression there. Now I'm going to use the power rule and bring this all up. So let's do that. So I've got log of 7 x squared. Subtract then log of 7 x to the 4th. And finally, log base 7 of y to the 1/3. I can do it all in one shot. This is, I'm subtracting, so this is going to be the quotient rule. So this will go in the numerator, this will go in the denominator. So the way I like to think about it, if you have a mnemonic, is that this is a division bar. When you see this, right? When you see this formula, think of this as, I mean, I know it says subtract, but imagine that this is a division bar. And then these two are gonna, when I go from right to left, these two are about to flop. Like this is division bar, numerator, denominator. It's a mnemonic, right? That's what it's, I mean, visually, that's what it seems like it's happening. So I'm gonna go log base 7, and then this goes in the numerator, this other expression goes in the denominator, numerator, and I'm gonna write plus, and I'm also gonna go, just to clean this part up, y to the 1/3 is the cube root of y. So I'm gonna go back and write it like that. Just, I think it's just a cleaner symbol. Here I can actually reduce. So what I have is log 7, reduce that 1 over x squared plus, is that right? Yep, log 7. That. And finally, I'm going to take the product of these two. So it will be the inputs, taking the product of both. So when I take the product of both, I really would have the following. And now I've done it. I've written as a single log. Okay. So I'm going to take this last one here. Everybody's expression is some difference of product of logs. So again, I'm going to expand again. So I'm going to start with writing a product, and a product. Oops. For all products. Like so. And this is log base 10. So don't have to worry about base. Then I'm going to use the power rule, bring all these down. And now this is the 5th root. So remember, imagine that I have 1 over 5 sitting here. So when I bring this down, what I have here is the 5th root. And now I can expand this further. So what I have now is 2 log of x. That's 4 log of y plus. And now when I expand this, the 1/5 is going to go to both. So I'm going to put parentheses until I expand log of x cubed plus. So again, using the product rule, log of y to the 4th, like so. And now I'm going to bring this down, and distribute. I'm going to just do it in one shot. So I'm gonna bring this down, distribute. So when I do that, I got 3/5 log to the x plus, then bring the power down here, 4 times 1/5, 4/5 log of y. So again, just to emphasize, we don't have a purpose right now while we're doing this. We're learning how to expand and contract for a different purpose that you'll see in a future section.